Happy almost Friday again. I hope everybody's doing well. We are going to continue on with our really fun factoring, and these ones are like the best. Okay, so these are some special patterns that you can recognize, and it's going to help you factor a little bit more quickly. So, the first thing that we're going to look at is if you have perfect square trinomials. And what this would look like, you would be able to recognize this because your first value would be a perfect square, and then your last value would be a perfect square. So for example, in this one, we have 9x squared and we have 4, which means both of these are perfect squares. So instead of doing like a tricky trinomial and saying, okay, what multiplies to 36 and adds to 12, and then doing grouping and doing that whole long method, which you could do to get the correct answer, if you recognize that it's a perfect square trinomial, all you're going to have to do is follow this pattern. So a squared, we would just write what a is. So 9x squared would just be 3x, okay? And then b squared, we would just write what b is. So 2 times 2 gives you the 4. So this would be plus 2. Okay, so this would be 3x plus 2 squared. All right, and again, if you didn't recognize that it was a special perfect square trinomial, you could do tricky trinomial and then do the grouping and figure it out. You'd get the same answer, but this is just going to be a much faster way. The other one would be if the signs are negative and then positive here, that's going to give you a negative a minus b squared. So same sort of thing though, you're looking to see if these are both perfect squares, and they are. So this gives us 7x, and then again, it's going to be minus here, and then 36 would give us 6. All right, so something like this is going to be super helpful, where this would be like a huge number if you were trying to do a tricky trinomial, and it would take you a really long time. Okay, so it's good to be able to recognize the pattern. So how do you know the given problem is a perfect square trinomial? So again, that's what we were talking about up here. Your first and your last terms are positive perfect squares. Okay, so they have to be positive perfect squares for your first and your last term. And then the b term, so that middle term, is twice the product, I should say product, of the square root of the a and c terms. So basically, if you do 2 times for like this first one, 7 times 6, right? So, oopsie. Um, so twice the product of the square root of a and c terms. So 7 times 6 is 42. 42 times 2 would be 84. Okay? So you can always double check it that way. All right, so if we look at these, okay, so again, this is a perfect square, this is a perfect square. They're both positive, so I know I'm going to get my a plus b and then squared. So 81x squared would be 9x, 25 would be 5, so my answer is going to be 9x plus 5 squared. Again, you could do a tricky trinomial, it would just take you a lot longer. Number 2, so 12 is not a perfect square, okay? So we always want to look for GCF first. So for this one, let's see. So 363. If we divide that by 12, it doesn't go in. Divide it by 3, it does, and 132 would also be divisible by 3. Okay, so first thing we're going to do is take a 3 out, which will give me a perfect square here. So 4x squared minus 44x plus 121. All right, so now we have both of these are perfect squares. This is a minus, so it's going to be 3, and then a minus b squared. So 4x squared gives me the 2x, 121 would be 11. Okay? So solving the following polynomial equations here, again, we're going to be looking for the same sort of things if we see those patterns. So for this first one, for number 3, first thing we always have to do, right, is set it equal to 0. Okay, and again, we always look for GCF first. So here we have GCF of 4, or sorry, of x. We're going to take out a 4x squared minus 4x plus 1. And now in this trinomial, you can see you have your two perfect squares again. So we have our x. We know that this is going to be subtraction because of the subtraction sign. And 4x squared would give us 2x. Square root of 1 gives us 1. Okay, so when we solve this, we have x is equal to 0 is one of our answers. We also have 2x minus 1 is equal to 0. You can write that out twice, but since you know it's going to be the same answer, you just have to solve it once. So we have x is equal to 1/2. Okay, so we have, whoopsie, supposed to be a highlighter, not crossed out. Okay, so x is equal to 1/2, x is equal to 1/2, which again, you don't have to write that twice, and then x is equal to 0. All right, so for number 4, again, get this all set equal to 0 first. Okay, so 10x squared minus x, or x squared gives us 9x squared plus 30x, and then 45 minus 20 gives us plus 25. So again, hopefully you would recognize that this is a perfect square, this is a perfect square, it's addition. So I know that it's going to be addition. 9x squared, the square root of that is 3x, and 25 squared, the square root of that, or sorry, 25, the square root of that is 5. All right, again, since it's to the second power, it's really 3x plus 5 equals 0, 3x plus 5 equals 0, but I know that's going to give me the same answer, so I'm just going to write it out one time to get x is equal to negative 5/3. If you write it out twice, so sometimes people will just write it out twice and write that answer twice, that's fine, but you only have to have it written once. Okay, so recognizing those perfect square trinomials is going to be very helpful in terms of making the problems a lot easier instead of doing tricky trinomials with them. So continuing on, we're looking at factoring high degree polynomials. So you're going to factor them the same way. So for example, number 1, we know this would be difference of 2 squares. So the only difference is this is x to the 4th. So what times what gives us x to the 4th would be x squared, and then minus 9 plus 9. So what makes this really fun is that you can then keep going here, right? Because now this is still dots. So this becomes x plus 3, x minus 3, and then the x squared plus 9. Don't do dots with that because it's not difference of 2 squares, right? It's addition. Okay, same thing here with number 2. So this is x to the 4th. So it's just going to be 5x squared minus 3, 5x squared plus 3. We can't go any further with this one since they're not perfect squares. Number 3, again, whenever you see the two terms, you want to look for GCF and then you want to think about dots. So this again would be difference of 2 squares. So 4x to the second minus y to the second, and then 4x to the second plus y to the second. As soon as it becomes addition, you can't do anything else with that. Okay, this one, both are perfect squares and it's subtraction, so it's still dots. So 2x minus y, 2x plus y, and then the 4x squared plus y squared just comes down into your answer. All right, so for number 4, 49x to the 6. Okay, so again, this is a perfect square, which is 7. And then remember, when you're multiplying with exponents, you actually add them. So it would be x to the 3rd, right? 7x to the 3rd times 7x to the 3rd would give you 49x to the 6th. and then the 1 would be minus 1 and plus 1. All right. For number 5, so we just have a normal trinomial. Make sure you don't do like a tricky trinomial and start grouping, right? If there's no coefficient in front of this first term, this is just normal trinomial. So what multiplies to 25 and adds to 10? Okay, so that would be 5 times 5. So instead of doing x and x here, because this is x to the 4th, we have to make this x squared times x squared to get that x to the 4th. And then again, what multiplies to 25 and adds to 10 would be 5 and 5. Okay, so sometimes people start doing tricky trinomials for every single trinomial. Don't do that if there's no coefficient in front of this first term. Then it's just an easy trinomial where you just plug it in. You can do a tricky trinomial, you get the same answer, it's just going to take you a lot longer. All right, so for number 6 here, the first thing that we hopefully see is that there's a GCF. Okay, so I'm going to take out a 12 and then get x to the 4th plus x squared minus 2. Okay, so now again, I have a trinomial, but it's x to the 4th. So I know this is going to be x squared. I know this is going to be x squared. And then minus 2. So what multiplies to negative 2 and adds to 1 would be a positive 2 and a negative 1. Okay, so multiplies to negative 2, adds to positive 1. This one is so good, it keeps going because this is now dots, right? So this becomes x minus 1, x plus 1, and then this stays x squared plus 2. So that was a really fun one. All right, 7 and 8 here. 7, again, hopefully you realize that there's a GCF of 3. So we get x to the 6th minus 2x to the 3rd minus 3. Okay, and we're trying to, again, it's an easy trinomial. So we bring the 3 out. We want what multiplies to x to the 6th, which would be x to the 3rd, x to the 3rd. And now we want what multiplies to negative 3 and adds to negative 2. So negative 3 times 1. Okay, so we're just going to write that in there. All right, and for number 8, we look for a GCF first. There's not a GCF. It's not a perfect square trinomial because the 3 and the 6 are not perfect squares. So it's going to be a tricky trinomial. So what multiplies to 18 and adds to 11, which would be 9 and 2. Okay, so we do our grouping, 3x to the 4th plus 9x plus, oopsie, squared plus 2x squared, since we want these terms now to add to 11x squared plus 6. So now we do our grouping and we take out a 3x squared to get x squared plus 3. We take out a 2 to get x squared plus 3. So we have 3x squared plus 2 and then x squared plus 3. All right. So these are basically just the steps for factoring. Okay, so you can kind of review this on your own here, but these are all the different things that we learned. We always do the GCF first, and then based off of the number of terms, we look at these different types of factoring. Okay, so again, this is everything that we learned with factoring. So you can, kind of look at that on your own, and if you have any questions, we can go over that during the group session.